All right, I want to talk a little bit about the labs you're going to be doing your investigations. Uh, this is where a lot of people have some issues. So I just thought I would begin to give you some ideas. So we're looking at surface pressure here on this map. The map has nothing else but that plotted on it. Every one of these is an individual site or location. Uh, for example, right here, 1012. That is Charleston, West Virginia. So you can see at this moment in time, on the 15th of August, 2022, at 17Z, which, if it's Eastern Daylight Time, would happen to be 1 o'clock in the afternoon. So this is pressures. They're all in millibars, which is a unit of measurement for pressure. We'll talk about that more later. So what you're asked to do here is connect lines of equal pressure. And interestingly, we only do it every 4 millibars. And some of the values, they're divisible by 4. So in other words, 1,016, you can divide 4 into 16 evenly. 1,012. So they're the values that I would want to analyze on this chart. And the reason I'm doing this analysis is to find the high and low pressures. So if I was to look at 1012, well, I got one right here. We know in Charleston we have one. We have one here. Well, yeah, but where do we go from there, right? That is one of the issues with this. Sometimes it's just that you can't go anywhere with them very well. So sometimes it's better to look, well, maybe we'll start out here. Here's a 1012. Notice everything down to this side of it, at least, is kind of a little bit lower, a 1010, a 1010, a 108. So we know 1012 is going across like this, going down through here and down through here. Everything above there is above a 1012. Everything below that line to the south and west of it. And we can go up the other direction and find a 1012 here, here, and there's 1017 above it, so we don't want to go there. So we basically have connected a 1012 line there. Here in West Virginia, I would argue that there's just a little circle of it. There's a 10, what looks like 1011, so here's a 1012, 1012, 1011. There actually might be a little low pressure right in there. So that's how you're doing this. It's not necessarily easy. It's just connect the dots. And the idea is, oh, okay, I have a 1016 here. Well, I have a 1018 here and a 1014 here. I got 1016. It's going to draw somewhere about halfway between the two of them. So that's how you do this part. So with that in mind, you're going to be answering some questions about it. And guess what? Here's that map. Remember I said we had a 1012? I thought a little, but right there is a little low. They analyzed it like I did. You'll see a big high pressure up here. So these will have bigger pressures. These will have lower pressure. So if I'm asking you to find the highest pressure on the map, I would expect you to be going to where the higher pressures are and looking around at them to see what values might be the highest. And the same would hold with lowest. I'm having you look for lower pressures. These are just some of the things you're going to be doing on the weather map. So your first assignment is basically going to be analyzing that, looking at this and answering questions about pressure, and maybe some other things you're going to see on the map. You'll notice it's every 4 millibars. So that means 1,000, 1,004, 1,016. The other direction, 996 millibars, 992 millibars. So keep that in mind, that those are the pressures you're analyzing. Here we got another map, has pressure. Oh, whoops, what happened? We were looking at 4 digits before. Why are we looking at 3 now? Well, we want to know pressure to the tenths. So if I want to know it to the 10th, I'm adding the last digit is going to be the 10th, and then the 2 other ones before it, which means I'm missing 2 digits. many times, 1 or 2. So if it's a pressure that is above 1,000 millibars, you're adding a 10. If it's a pressure below 1,000 millibars, you're adding a 9 to the front of it. Now, key thing for this course, 99% of the time, if the pressure is between, if you see a number here that is between 500 and 999, that is going to have a 9 in front of it. If you see a number that is between 0, all zeros across, to like 499, that number is almost certainly going to have a 10 in front of it. If you look at lows and highs, you might be able to determine it's sometimes lows get a little lower than that, and sometimes highs get a little bigger than that. But for this course, that's pretty much the range you're going to be looking for. So with that, let's take a look at a current surface weather map. Notice there is a symbol. This is Beckley, West Virginia. Left-hand corner, that is the current temperature. Left-hand bottom, that is the current dew point. That is a measure of moisture. The closer they are together, the more the relative humidity is. The further they are apart, the less the relative humidity is. So now you've just read the first part of the station symbol. Oh, here's this pressure. It's upper right. So 154, I would put a 10 in front of it. That is 1015.4. Now, in the middle of the circle, you'll notice it's all collared in. That means it's cloudy. Whatever. You'll notice over here, for example, there's no collaring whatsoever in the middle of the circle. Guess what? That's clear. It's sunny over there. Now that we've come to that part, what about the wind? Yeah. This arrow, this barb right here is your wind. So think of a compass going around here. 360 degrees is due north. 180 is due south. 270 is due west. 90 is due east. This always represents a direction on a compass. So if it's coming in on the southern side of the station, that means the winds are coming out of the southwest in this case, from about probably 200 degrees. So we have a southwest wind. Winds always are coming from, as a meteorologist. So, for example, over here, I look at this one. I have a southeast wind. The wind, again, is on the southeastern side of the thing coming towards it. Now, I want to know how strong the wind is. See these little barbs here? The larger ones, like that, like this, are 5 knots. The small ones, like this, are 10 knots. 10 knots, I'm sorry. I don't want to make it any tougher. The small ones are 5 knots. So you just add them up, and you'll see there's a 10. Up here, we have a 10 and a 5, so that's 15 knots. Also, look over here next to this station. You'll see 4 dots. Dots represent rain. 4 stars would be snow. These are your precipitation. You can also have cloud, fog, for example, or haze. All of those could be over here on your left. Here you have nothing, so no precipitation, fog, or haze is occurring in Beckley at this moment. But here there's 4. 4 means very heavy. If you only had 3, it would be moderate rain. If you had 2, it would be light rain. Here you have another heavy rain up here. So get used to reading this. This is the kind of thing you're going to see a lot throughout this course. And you're not just going to see it at the surface. You're going to see it aloft. The principle is the same. Notice that I'm picking out boundaries here. We have a warm front across West Virginia. Notice the wind southerly here to the north of it. Winds are a little more different. Out here, we have this low pressure. Winds are turning into the low, just like we've talked about. One last thing I wanted to show you. It's called a Stubbe diagram. What it is a means of looking at temperatures and dew points and wind in the vertical. I want to know what the atmosphere is all the way up, as high up as I want to go, probably to about the stratosphere. So in this case, all we have done is taken pressure, 1,000, 900 millibar, 800 millibar. If you go up higher, your pressure is going down. And off of that, I have plotted a temperature. This is the x coordinate is across down here is temperature. The y coordinate is pressure. So with that, I have plotted a temperature here. So I know the temperatures and I know a dew point. This is my dew point. Notice the dew point's always going to be a little lower than temperature. It may be exactly the same. It'll never be higher than temperature. So the further apart they are, the less moisture is in that area right there. The drier the air is. The closer they are, the wetter the air is. So all this is a lot of temperature, a lot of dew point. And here you have the winds. Notice they vary with height. And they get stronger the higher up you get typically. So these are all going to be useful in your first several weeks learning about these labs. If you have questions about them, I want you to ask me. So hope this helps.